all weird.
Assume that 30% of students at a university wear contact lenses. Peyton.
Have them or wear them. There's two different things. There's two different things.
Well, you don't have either of them.
Yeah, it's either.
We randomly pick 100 students.
Okay.
What are the mean and standard deviation of the proportion of students in this group who may wear contacts? So what is the mean?
30 students.
So 0.3.
Wrong.
It says 30%.
Well, I mean, I was going off of, like, the proportion of the students in the group.
Okay. Standard deviation
How do I do standard deviation?
is
Square root of P times Q over N.
0.3 times 0.7 over 100.
It's all under the root. Okay, yeah. Right, cool.
Yes, all of it is.
4.05.
So I'm just going to call it 0.046.
Or that. Tablet students.
All right, let P hat, oh look, the little hat's on it this time.
Oh.
Represent the proportion of students in this sample who wear contacts. What's the appropriate model for the distribution of P hat? So we're going to, are the conditions met? It's the first thing we always want to check.
Let's see. Is it random?
I mean, it says
Though.
randomness.
Yes.
It's pretty random.
Perhaps it's random.
10% is 100 students less than 10% of all students.
Like,
All university students?
I guess.
Yeah.
I mean, it
probably.
depends on what
Small
university.
Well, it means university students,
Oh,
All.
across the globe. Oh,
not just at that particular one.
Okay.
Yes, I would say yes.
So it's not like just at this university.
Correct.
It's at
Okay.
a university.
Okay.
Yeah.
So it good. It's check
And
that
then-
one.
What's the F?
In
By F?
okay. What?
Yes, by F.
Success/failure.
Oh.
So n times p has to be greater than 10. So n
So,
is it 100?
Are they independent?
It is 100.
Are they like independent enough, I guess? Is that like
Well, yeah, because one student wearing contacts isn't going to affect another student wearing contacts, right?
Yeah.
I guess
Unless you like punch them in the eye or something.
Maybe they're like related or
interest
something.
pay is definitely greater than 10. I would say.
So the conditions are met.
Conditions are
You know, that would just be 30 and 70, right?
met. Yes.
I'm writing it
I
out.
did.
Okay, that's
I
fine.
did find that out.
I thought you were trying to like type them all in and figure it out.
Once I did the first one, I was like, yeah, that makes sense.
So yeah, so you're welcome to write them out, but this is a lot of times what I end up doing is just writing it like this that just says conditions are met.
Okay, so in every problem, we won't have to like.
You don't necessarily need to write it out all the time. Now, when you get to the AP exam, like I would say yes. So probably when you get to the test, it would be beneficial to write out what they are. But in every single homework problem, as long as you're thinking through the steps and making sure they're there, you should be fine.
So just as a little refresher, what are all of the conditions?
Did we not just go over them?
Is it random? The 10% thing. The
Random 10% thing.
Do we have to draw the
What's next?
and then
60,
success/failure. So
97,
n
That's only if it
times
asks us
p
for it.
has to be
Okay.
greater than or equal to 10.
So we do not.
And then n times
So is
q
that all we
has
have to
be
do for
greater than
this
or equal to
part?
10.
No. So what is the appropriate model for this distribution? What does that mean?
Is it normal?
It's normal.
Oh, yay.
So it'd be the normal model. And the way that we denote that is in parentheses 0.3, 0.046. So mean standard deviation. Need to adjust the brightness again. This is like, there we go. The next question asks for the assumptions, which you just technically did, but
Wait, what are the assumptions?
what assumptions? So, like,
Oh.
the stuff that we just said basically goes in this part, but I didn't read down and see that that's what this question was.
Oh, like the condition stuff?
So basically, is it random? They're randomly picked. Okay, because it says explain, so go through and do that. 10% condition. 100 students. Less than 10%. All university students. If you already had written them, like let's say this happened on a test, like you didn't read that question C was specifically that, and you had written them in part B, you could just draw an arrow down to it so
Okay.
that I knew. So you don't have to like rewrite it, but
But like on the exam, we wouldn't do that. We'd just rewrite it.
well, on the exam, the way that they don't usually like it doesn't give you a space in between each part. They're usually going to give you like all 6 parts, and then you're going to go through and work them out. And then you just need to label each part. So you would just mark out and just write that that was part C or whatever. Success failure, we said that was met because NP is greater than or equal to 10. NQ is greater than or equal to 10. What you got, Nathan?
Yeah, I got a question. I'll just say you.
So on number
I was
eight,
about to say,
could you
yeah.
like kind of explain like what I'm trying to do here? I don't remember doing a problem where like the instructions were like this.
Oh, I forgot to tell him that it was a multiple choice question.
Oh yeah.
You,
You're saying you have my quiz.
yeah, I do. It's right here upside down. Good job. So you're gonna do this the exact same way if I didn't give you all the answers. So solve it like you normally would,
Okay.
and then make sure you look out to the decimals because obviously I've chosen numbers that are very similar to each
So
other.
it's a multiple
Make sure you're
choice.
careful in picking. But I will look at your work on that problem, Josh, and see.
Okay.
So if you picked the wrong one, because well I can't say it, but
I know what you mean,
if you picked the wrong one, then let's say you have the work right and then you maybe just didn't pay attention all the way, then you know.
Well, that's all like 13.
That would
Does that help?
That would
Yeah.
Can't tell you how to do the problem, but
I didn't know it was like a multiple choice problem because like.
you were like, do I have to do all of these?
Yeah, I
That
was
could
like,
damage
It's the
your
same as like the
brain.
square root of like 80 that we had. You do it the same way. You're just doing it with that number instead.
It's like what? Like you have like a
I'm
formula
but
with
amazing
dyslexia?
that number.
Yeah, I gave you and I told you what number to
Dyslexia,
use.
Okay.
Cause like I think that was like the cube root of 66, right?
Yes.
And I said to use the cube root of 64 to solve it.
To it, I mean, talk to it.
So yeah, you're gonna do it the same way.
And
Get out
close the
so
door
we can
I
talk about it.
Close the door and leave. Bye now.
So okay.
So when you when you put it in the calculator, it's not exactly the same going all the way out as like doing it.
You'll have to. It was I had one rounded decimal at the end.
Okay, yeah.
It was.
What did you get?
I don't remember.
Really fast.
C maybe.
I think the one with the like one with super or something.
It was B.
Can I see what B was?
4.0417.
Okay, I got that.
Quite a few people selected the 4.0412.
That because
Yes,
that's what you
I
get when you
think
put
I
it in the
certainly
calculator.
If you just type in the square root of 66.
Yeah.
But that's
But
not
I
what you
did-
needed
I
to do.
certainly did do that because I did it the other way and I got an answer that was
That's
not
why I
bad
put that
at
answer
all.
on there.
Well, what did you get?
An answer that wasn't an option.
Well, you know what I was doing at first? I wasn't doing the cube. I was first doing the work as the square root. So I was like, why am I getting 8? Because I was doing 8 plus a thing.
Mm.
But then I finally realized and went back and did
No,
it.
yeah, because I was like, and then I did the square root of 66, and I was like, well, if this is the answer, why did I have to do the other stuff?
Because it wasn't the answer.
wasn't
Right.
No, that's why I intentionally did it. Because I just didn't ask you to tell me the error by which you were off, basically.
Yeah.
Yeah, I don't know what I did wrong, so.
But if you have the work, that's why I said on those ones I will look at the work. But on the AP exam, they would not.
Yeah.
They might not be quite as cruel, but they would give you two answers very similar like that to make sure you didn't just type it in.
These is mini butt.
Okay, and then I got
So why
one
do they
problem that
give
I
you
got the points on.
different answers?
I got one problem I didn't get the points on.
What do you mean?
Problem is different.
Like if you like work it out or put it in the calculator.
Because it would be different answers, because one's an approximation and one's an exact value.
Yeah. When you put it in the calculator, that's the exact value, right? But doing it by hand was the approximation. We learned how to do it.
So the correct answer is
The
not as
approximated.
right
Well,
Technically.
right, because, well, it is the right answer for the given situation.
For the situation, yeah.
It's called a linearization.
answer. I like lines.
It's not, well, I guess it is a line, but,
Not really.
It's not fun.
I mean, it makes an equation of a line, but it's a tangent,
Ooh, tangents. I like
which is what we seem to be getting off on a lot of today.
See, this is why
I think it's
like
just the
tangents.
nature of the week. Okay.
Okay, let's go.
What is the probability that more than 1/3 of this sample wear contacts? So what does that mean Y bar would be?
0.33.
So Y bar is going to be 0.33 and repeating, but I'm just going to call it 0.33.
How did we know that?
1/3 of this sample.
Oh, yeah.
So, using Z,
We love Z.
I hate
Y bar 0.33 minus mu 0.3 over standard deviation 0.046. And I have a whole bunch of random numbers written on my paper because somebody gave me some false information one time.
It wasn't me.
It wasn't you,
It
obviously.
wasn't me.
Wait, what?
Like somebody gave me some false information when we solved these before.
Oh.
So I have like numbers in here and crossed out, but I don't know which one's right. So I want to make sure. So y'all type it in and make sure.
0.652.
Yeah, one time somebody had given me 0.725.
No.
And I was
I
like,
don't know how you got that.
I don't either.
I just turned British. I don't know.
So this would be that more than 1/3. So that would be the probability for Z being greater than 0.652, which we can approximate using normal CDF, or we could use our handy dandy little table if we were so inclined.
I'm not feeling the table.
Yeah.
I ain't feeling it.
I think we've used the table enough that if y'all were forced to use the table
I know
versus
how
the
to use
calculator,
it.
you'd know how to do it.
I know how to use it. I just don't want to use it.
Well, that's why normally after like the first section of it, I don't use it anymore. But then I'm like, honestly, you probably should know how because if it's on a no calculator part, you'd have no choice but to use it. So normal CDF of 0.652, 1E99,
What the heck is that?
0 and
It's
1.
just like to make it
Girl,
a
I
really
can
large
tell
number.
you.
Yeah, it just needs to be a number bigger than what we have. So that's just the
It's not actually
choice.
that scared.
She's like, right, but she don't really.
Like it's best if it's like a really big.
Emily listens to our class and is like, phew, I'm not there.
This is why. I got
And that's what you said in
I
that
did!
video.
I can't.
They were like, because today was just a notes day, because I wasn't sure if they were going to be done originally when I planned for this week.
Yeah.
So I was like, all right, just watch notes today. And they just started laughing, and I was like, what? And they were like, you said something about we're going to have to do some explaining. And Peyton's like, I ain't going to do that. I said, then don't take stats. And she goes, I don't plan on it.
Oh, that's right.
I did say that.
That was crazy.
That was funny. All right, what do we get when we do this?
0.257.
7.
Maybe that's no,
What?
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 no.
So then, to conclude this, because we would want to have a conclusion here,
Why you just
according to the normal model, the probability that more than 1/3 of students in this sample wear contacts is about 0.257 or 25.7%. All right, we get all that. All right, notice part B is the conditions on this one.
Okay.
All right. A national study found that 44% of college students engage in binge drinking. And let's start that college we discussed this morning. 5 drinks at
Gotta
a
be hidden somewhere.
sitting for a man, 4 drinks for a woman. Or 4 women. Use the 68, 95, 99.7 rule to describe the sampling distribution model for the proportion of students in a randomly selected group of 200 college students who engage in binge drinking.
I hate this rule.
All right, so let's start out with mean and standard deviation. So mu of p hat is what? It's given to you. 0.44.
Oh, I haven't written that. But
Standard deviation. I thought you were going to be Nathan. Of p hat is square root 0.44 times 0.56 over 200, because that's a number of students we're looking at. I'll just call it 0.035. So I'm gonna set up my handy dandy model here. I don't. I never look right.
I don't either.
They're always lopsided and it really irritates me.
No, it's not. Look, it's pretty symmetrical.
I think I have pretty decent practice drawing things like these from all those graphs of,
Oh, the parent functions?
yeah,
Ooh, have fun with that. Do you have a quiz tomorrow?
no, we had like a test on Tuesday.
Oh.
Like it wasn't particularly hard, it just took very, very long.
Algebra 2 has a quiz tomorrow and is doing the same thing.
Oh, is
I'm
that
forcing
why
them to
that's
actually graph trig functions in Algebra 2. I'm being cruel. All right, how do I find these values down here? Or
Like,
let me rephrase. What are they? I think y'all know how to find them.
Alright, 0.475, 0.51, and 0.545.
Remember when all the TLC kids thought we had like the strongest accent
This is
ever?
probably how I sound to them.
I know,
Yeah.
they kept telling us we had accents. I'm like, what?
0.405.
well, I mean, maybe you do, it's just, like you're
The
used
one
to
girl
it.
was like, no, they really don't have accents.
0.37.
0.335.
ideas.
All right, so where's 68?
First standard deviation.
$95.
2 standard deviation.
And 99.7.
3 standard deviation.
What's everything else? I'm getting crazy here, people.
Above 3.
Anything more than 3. Yep. Is that final 0.0 or 0.3%? All right, so now a couple things about this problem. Typically, if you were on an AP exam, what you would need to write is something along the lines of, I'm not going to write out the whole thing, but according to the normal model, about 68% of samples of size 200 are expected to have 40.5% to 47.5% binge drinkers, about 95%, and then you'd keep going with that, following that pattern all the way out till
Oh, okay.
the thing. Okay, so that would kind of be the explanation of that. I'm not going to ask you to do all of that because I think you understand that, but know if this was a short answer question, you would want to explain what that means. Okay, they're getting points on this exam is a lot giving explanations of why things are what they are. Okay, I know that you know, but these readers that are reading your test don't know, right? Like, they have no idea what you learned or whatever if you just happen to know that that diagram should look like that. But they want to know that you know what that means. Okay?
This is what happens when short answer becomes long answer. Are you okay?
Yeah, I was confused on why you were like,
I was just like stretching my arm,
I was like, what is happening?
just making
Really
sure they
bad
weren't
spread.
like, you know, kind of stuck, I guess.
All right, so conditions. Okay, do you think the appropriate conditions have been met? Is it random?
Yeah, I'd say so.
Yes.
Okay, yes, it says randomly selected, so yes.
Like, that's a good answer for that. Like, if it just says randomly. that works.
I would probably reiterate because, like I said, these aren't going to be, like, in gaps. So I would reiterate, like, it was randomly selected from 200 students. So I would say, like,
Could you just check my formula to see if that's the correct?
I didn't check anyone else's formula. If I had, I would, but I didn't check anyone else's. Right? Nobody else asked me to check their formula, right?
For what?
On the cone problem.
I guess
Oh,
so.
no.
Okay.
Right? No, it's not the problem.
Yeah, I don't know about the problem formula.
Yeah, the one
We
goes.
got the formula right.
So I would say something like that. Randomly selected 200 students for the explanation of that.
Okay.
Success failure. So I would, show the math. So I would show the n times p. And I would actually show out that you're multiplying 200 times 0.44, which would be 88. And n times q is 200 times 0.56 is 112. And I would just put a thing that, like, both of those are greater than or equal to 10 to show that that condition is met. Like, kind of like that. %% condition. Yes, no.
I would say yes.
Why?
Because It's
200.
less than 10%. 200 is less than 10% of the like total college students.
Yep.
Is there like ever a time where it's not less than 10%?
Very, very rarely. It would have to be some like random like problem for it to not be less than 10%. Or some obnoxiously large number, like they pulled the entire United States or something. Like
two of these tigers, but then you would have to know that there's actually only 4 in existence. Oh wait, no, like you know what I'm getting at, but the numbers are wrong. You know what I'm getting at.
I love how you were like really trying to
she
get
was
me
so
to it.
confident, and then she's like,
And she's like, wait
Just
a
kidding.
The
minute.
numbers aren't right.
Wait a minute.
so then at this point I would say like all conditions are met.
But you know what I'm getting at, though.
Yeah, I got you.
So normal model is appropriate. And then we would write what that normal model would be, which would be 0.44 and 0.035. Like that.
So like if the conditions are not met and like they have all of like the things there, like what we would do if it was met, and do we just like stop where it's not met and then be like, yeah, I can't do the rest of this because the conditions aren't met.
If you think that they're not met for some reason, or unless it specifically says something that tells you that it's not, I would probably say, like, the following will be worked as if they are met, but they are not met, or something like that. I don't think I've ever seen a problem that that's been the case for. Between our book and the prep book, they're going to be met. But it's more like if you get out in the real world and you're doing these, you need to make sure the conditions are met.
Yeah. Because like they're not just gonna give you like freebies like that. I don't think on the AP does.
Yeah, that would be kind of
Not really.
No, yeah.
too easy.
Like these.
All right, after hearing of the national result that 44% of the students engage in binge drinking, a professor surveyed a random sample of 244 students at his college and found that 96 of them admitted to binge drinking in the past week. Wow.
That's weak. What were those finals?
Must have
That'd probably be the worst time to do it.
True.
It might have been like after finals, and they just they knew they failed. So.
Should he be surprised at this result?
So the mean we know is 0.44, right?
Right.
Yes.
Standard deviation now
We got it.
is going to change.
Yeah.
Okay, and actually our mean is going to change. This is the national result of what it should be, but we're going to see what the mean for this particular situation is. So we're going to do y bar. Okay, now again, let's say we hadn't been asked in Part B about the conditions. I would want to look at the conditions here and note that they are met, okay, if that wasn't there. So I would basically just do something like conditions, because again, we have changed the problem a little bit. He randomly selected, okay, 244 students. That's more than the 200 that was before, but still less than 10% of the total. Things like that is what I would want to be looking for when the problem changes, even within the problem that we're doing. Like, just make sure that it didn't change drastically to the point where there's an issue now. All right, y bar is going to be the mean for this particular situation. So how would I find that? How many students admitted to it out of the number who?
96, so
Okay.
like 96 divided by 244.
Yep. So that's going to be
Good, turn up.
0.39. The standard deviation for this is going to be the square root of 0.44 times 0.56 out of 244. So the n just changed for this.
Oh, so we don't put that new?
No.
Oh, okay.
We're still using P and Q for that, and P didn't change. The standard deviation for our particular problem is changing, but not everything else.
0.032. Oh, it's already there.
Yeah, I went with what was on my paper was right, 'cause we're trying to finish this up. So Z is equal to Y bar 0.39 minus 0.44, which is the mu, over the standard deviation 0.032.
Did the bell ring?
Yeah.
Yes.
I'm just trying to finish this problem really fast.
I just couldn't figure it out. I was like, did I hear it?
It's negative
Yeah.
1.56.
Interesting. Okay. So the model we're looking at here, okay, whoa. The mean is 0.44, Y bar is 0.39. And so basically what this has told us over here, this Z value is telling us that that 39% is 1.5 standard deviations below the mean. Or I guess I should say 1.6, right? Because that rounds, yeah. Below the mean, which is not terribly unusual. I think I just spelled terribly wrong. I did. So basically, he shouldn't.
From Mrs. Jones.
Oh, okay.
Thanks, put them on your desk.
Yeah, thank you. So he shouldn't be too surprised, basically, by the result that he got. If it was more than 2, he would be. So remember, Z can tell us how many standard deviations away we are when we're dealing with normal model.
Okay.
So.